Hey folks, welcome to my channel number 10. So there we have the problem on the screen. Integrate the following with respect to x. We have 1 divided by square root of 9 plus 8x minus x square. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. So that's my y, integral of dx by square root of 9 plus 8x minus x square. Now I notice that I have a quadratic expression inside the square root, right? So like we have done in the previous videos, the idea is to reduce y to the format integral of dt by square root of x square minus a square, right? Hey, but wait a minute. In this particular problem, we see that I have a 9 plus 8x minus x square, right? So the most likely format we will arrive at for the quadratic expression is a square minus x square instead of an x square minus a square. And let's see how to go about solving this particular problem. So for a minute, I'm going to keep my y aside. I'm just going to pick the quadratic expression and rewrite it in the format we just discussed. I have a 9 plus 8x minus x square, right? The way I'm going to write this is 9 minus, then I open my bracket and I will get an x square minus 8x, right? I hope you folks are with me. Nothing changes the expression. And now I notice that within the bracket I have an x square minus 8x, right? Which means I can write my 8x as 2 times 4x. And then if I add and subtract a 16, it still does not change anything in the expression. So all that we have done is written my 8x as a 2 times 4x, and then we have done add and subtract 16, right? Now I can combine the x square and minus 2 times 4x and plus 16. Let me highlight this in yellow. And why can I combine this? Because I know that this particular expression in yellow is nothing but an x minus 4 the whole square, right? And why is it x minus 4 the whole square? Because my a minus b the whole square is a square plus b square minus 2ab. And therefore, when I rewrite this, what do I get? My 9 minus of 16, right, becomes a 25. And then I have a minus of x minus 4 the whole square, right? Which means my 25 is nothing but a 5 square, right? So I can rewrite this as 5 square minus x minus 4 the whole square, right? I hope you folks are with me. So let me go back to my y, write it in the format what we just arrived at, right? So my numerator is still dx, but my denominator inside the square root becomes a 5 square minus x minus 4 the whole square. So that's my y. Now, in order to reduce it to the format integral of dx by square root of a square minus x square, what is that substitution that I need to do? I'm sure by this time all of you are quite familiar with this substitution. If you have not yet understood what I'm trying to do, take a look at some of my previous videos or do write in the comments and I'm happy to help you personally. Right? So I have t equals x minus 4, which means my dt equals dx. And then I go back to my y, try and express everything in terms of t now. So my dx becomes a dt and my expression inside the square root becomes a 5 square minus t square. Why? Because the substitution what we have made is nothing but t equals x minus 4 and x minus 4 the whole square becomes a t square, right? So now you take a look at this. We have arrived at the format what we wanted at the starting of the problem, right? So integral of dt by square root of 5 square minus t square. Now to solve this further, we need to make one more round of substitution. And what is that? This time it is going to be a trigonometric substitution. And whenever you have integrals of this type, you need to remember the three formulas: sine square theta plus cos square theta equals 1, secant square theta minus tan square theta equals 1, and then I also have a cosecant square theta minus cot square theta equal to 1, right? And in this particular case, the most appropriate substitution would be t equals phi sine theta, and which means my dt becomes equal to phi cos theta d theta, right? So I have my t, I have my dt, I can go back to my y and put back everything in terms of theta this time, right? So what happens to my numerator? Numerator is nothing but a dt, which becomes a phi cos theta d theta. And then my denominator becomes a root of phi square minus phi square sine square theta, right? What happens is I can remove my 5 out of the square root, because phi square root of phi square is nothing but a 5. And then what I'll be left with a square root of 1 minus sine square theta, which is nothing but a cos square theta. So let's write that. Now we know that 1 minus sine square theta is nothing but a cos square theta. And then a root of cos square theta is nothing but a cos theta again. So what are we left with? We are left with integral of my numerator. Let it remain as it is now, phi cos theta d theta. And then my denominator becomes a phi times cos theta. Now you see, from here on it gets a lot more simpler, because I know that my cos theta and cos theta can get cancelled out, and so is my 5. So I cancel out my phi, I cancel out my cos theta, I'm left with integral of d theta, which is nothing but theta, right? So let's do that in the next step. So I have integral of d theta, which is nothing but a theta plus c, right? So while I've arrived at my final answer, I know that I need to put back everything in terms of x, right? So let's go back and do the appropriate substitution. So you notice that I've made two substitutions. The first one being t equals x minus 4. Let me highlight that. And the second one being t equals 5 sine theta. Let me highlight that as well. Now I'm going to put back everything in terms of x. So let's start off with the most recent substitution, which is t equals 5 sine theta. If t equals 5 sine theta, then my theta equals sine inverse of t by 5, right? I hope you folks are with me. And then I have my constant c. And then now I go and do the substitution of t in terms of x, which is nothing but an x minus 4, right? So now I think I have the final answer. Let me bracket this x minus 4 by 5. So there we are. The final answer to the problem is y equals sine inverse of x minus 4 by 5 plus your constant c, right? So let me highlight my final answer in pink. So I hope you found my content useful. Please do subscribe to my channel and support.